Assalamu alaikum wa rahmatullahi wa barakatuh. Today we are looking at the second aspect relating to falling bodies. We discussed the equations that are relevant and what do they mean. We look at that beautiful simulation that we've got from this website that it is freely downloadable. And today we will look at a second sum related to falling bodies. Example 2. What happens when you throw an object upward? In the last case, we looked at what happens when an object is dropped. Now, if you throw an object upward, let's just look at this example. An object is thrown vertically upward with an initial velocity of 15. So here's the ground, and you have your object. An object is thrown initially upward with a velocity of 15 meters per second. Now here it is important to consider the 3Ds that I mentioned. We've got our diagram, we need direction. I always take downwards as positive. You could take upwards as positive, and then we have to work out our data. Now in the first case, in the first example, our initial velocity will be, because you're throwing it upwards and downwards is positive, it will be minus 15 meters per second. And then because you are throwing it upwards, as it goes up, what happens when it reaches the maximum height? The final velocity will be 0. Now this is very important that we realize that when you throw an object upwards at its maximum height, the final velocity is 0. Although the acceleration is not 0, it will stay the same. And gravity, we're saying that the acceleration stays the same throughout the motion, and in this case it will be 9.8 meters per second throughout the motion. So we've got three unknowns, and we want to know what is the maximum height reached, which is the delta x or delta y in this case. So if we work it out, we see that the equation that we have to use is vf squared is equals to vi squared plus 2g delta y. And your final velocity is 0. Don't forget that. Your initial velocity is minus 15, which must be squared, plus 9.8 is your gravity, and your delta y is what you want to find. So if you work this out, let's just see what we get. 15 squared is 225. Take it on the other side and you divide that by 2 multiplied by 9.8. You get an answer of 19.6. So we see that your delta y will be minus 19.6 meters. Now, why is the answer minus? It's because what happens is you're taking down as positive, and as this object is going in the opposite direction of down, this will be 19.6 meters upwards. So that's the first answer. The next question is, how long does it take to reach maximum height? So here you have to work out t, and you can use the same data, and you have to work out t. So the equation you can use is vf is equals to vi plus a or g delta t. Your final velocity is 0. Your initial velocity is minus 15 plus your gravity is 9.8, and t is what you want to find. And if you have to work out t here, you see that we get an answer of 1.53 seconds. So that is the time taken to reach its maximum height. What is its velocity at its maximum height? The velocity at maximum height will be 0 meters per second, because it slows down and stops as it reaches its maximum height. But the next question is interesting. what is its acceleration at maximum height. And as I mentioned earlier, the acceleration throughout the motion will be 9,8 meters per second downwards. So although the object stops in terms of its velocity, the acceleration throughout its motion is 9,8 meters per second. So throughout the motion, gravity is pulling downwards at 9,8 meters per second downwards. That is very important. So this is a basic sum related to an object being thrown. And just to check our answers in terms of the Java applet that we have, if we have our case where if we just look at it again, we said our initial height is 0, it's taken up from the ground, and your initial velocity is 15 and your gravitational acceleration is 9,8. So if we play this, let's restart it, and then we see, if we look here, we must get a velocity of 0. We'll see. Let's just get it, take it step by step till the velocity becomes 0. As you can see here, the velocity is getting less, 0.79, 0.59, okay, and we got a time there. It may not be exact. The time is 1.52 and the distance is 11.48. I think this will be the best answers to take, where we can see our time is 1.53 seconds and our height from the ground to the maximum height is 11.48. So let's just compare that to what we have. The time is 1.53 seconds and your height will be 11.48. And if you look at it, we see that our time is 1.53 seconds and our height was, according to this, it must be 11.48 meters and we have 19.6 meters. Let me just double check that for us. And actually that is correct, it's 11.48. So there's a mistake in our sum, so the 11.48 is correct. So if we recalculate this, we see we do get 11.48, and let me just correct that error. And we see that the proper answer will be 11.48, and that is a silly calculator error. So here we see that the Java applet, again, the position versus time graph is a curve. Velocity versus time graph is from 15 to 0, and your acceleration time graph is constant at 9.8. So this is a simple way of dealing with a sum that is thrown up from the ground. Thank you for your time.